Let's look at a typical question. So at equilibrium, a solution of vinegar contains acetic acid solution, and so what this tells us is that the concentration of acetic acid is 0.0787 molar. The concentration of hydronium ion at equilibrium is 0.00118 molar, and the concentration of the acetate ion is 0.00118 molar. And we're asked, what is the value of Ka, the acid ionization constant for acetic acid, or in this case vinegar, and what is the pH of this solution? So, a best place to start really is to write a balanced chemical equation for this. So here we have acetic acid reacting with water, and this is the acid, so it's going to accept a proton, it's going to produce H3O plus, and then there's going to be the acetate ion here, and of course this acetate ion is the conjugate base of this acid. And so the next step would be to say, well, what's the equation for Ka? Well, Ka is the concentration of the products over here divided by acetic acid, the reactant, and of course water, H2O, which is a liquid, does not appear in this expression because it has an activity of 1, just like in all of the equilibrium calculations that we did before. And so at this point we could say, well, we actually know this value here, we know it here, we know this value for acetate from here, we're also given the value of acetic acid, so this is relatively simple. We just plug in the values and into this equation, and we end up with a number that's 1.7 times 10 to the minus 5. Actually, if we think about this number briefly, this number actually is very small, and because this is very small, what this is really saying is that this reaction lies predominantly to the left hand side, and so this is actually a very weak acid because you have a very small Ka value. And then we're asked, the next question that we're asked is, well, what's the pH of this solution? And so the definition of pH, of course, is pH is minus log to the base 10 of the concentration of H3O plus, and we're actually given H3O plus concentration in the question. So it's relatively simple. We plug it into this equation, and we end up with a pH of 2.93. And so that's a typical way of going about these types of questions.